right, there are several tricks that you can use when balancing equations. I mentioned a couple already. For example, grouping polyatomic ions is always a big one. Depending on like the order, knowing which way to balance. But this is one you can use a lot. It's using decimals. And so I want to go back to a problem we've already done, and that's this KCl03 problem. So if I make a list, we've done this before, but just bear with me. There was 1, 1, and 3. There was 1, 1, and 2. And so everything was balanced except oxygen. Now, what would we ideally do? We'd like to just be able to change the oxygen, which we can. Look, oxygen's by itself here. So any number we put in this spot only affects oxygen. So the idea is, what could we put there to give us the correct number of oxygens? We need 3. But this only comes in groups of 2. So there's some number we can place there to make this number here a 3. And that number is 1.5. So if I put a 1.5 there, this is a balanced equation. Everything is equal. It's all balanced. It's not technically a legal equation. We're not really supposed to have 1.5 O2s, but this gets us to the point where it's balanced. And sometimes that's tough to do. This one I don't think is particularly tough, but I just want to use it as an example. So once it's balanced, then we got to change it so they all are whole numbers. So what you do is you look at your decimal and you say, what can I multiply this whole thing by to get whole numbers? So in other words, what can I multiply 1.5 by to make it a whole number? And the smallest number I can do that with is 2. So I'm going to multiply everything by 2. So right here, this is really a 1 in front. I'm going to double it and make it a 2. I'm going to double this 1 and make it a 2. And I'm going to double 1.5 and make it a 3. And when we look this over, this is still balanced, but now it's fixed. It all works out. And so I have 2 Ks, I've got 2 Cls, and I've got 6 Os on both sides. So again, you might say, well, what's the point? I could balance this without a decimal. Well, let's go to this next problem. This is a combustion reaction. They're very common, and they're typically difficult to balance. We did one in the other video, CH and O. So I'll just make a list once again. So 4 carbons, 10 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, 3 oxygens. So one trick to combustion is do oxygen last. So let's do that. Let's get everything except oxygen done. So a 4 here gives me 4 CO2, 4 carbons, and I'm going to need a 5 here to get my 10 hydrogens. Notice I kind of skipped a step. I waited to add up the oxygens until I was done with the carbon and hydrogen. So 4 times 2, I have 8 oxygens here. 5 times 1, I have 5 there, for a total of 13. So everything is balanced except for oxygen. And all I really have to do is place some number in here to get the oxygen to balance. I really don't want to mess with anything else right now because this is sort of a complex equation. I really only want to change this. So what number can I put there to get the O's to balance? Remember, I need 13 O's. So what times 2 gets me 13? 6.5. So 6.5 times 2 gives me 13. This equation is balanced. It was a lot easier than doing trial and error. I certainly could do it that way, but I don't want to. So now that the equation's balanced, I'm just going to get rid of the decimal. So again, I'm just going to double everything. I'm going to make this a 2. 6.5 becomes a 13. 4 becomes an 8. 5 becomes a 10. And I can go through and do my inventory. This will be 8 carbons, 20 hydrogens, 26 oxygens, and the same thing will be on the other side. It's still balanced. Just make sure you always multiply by the smallest number possible. If I multiplied by 4 across the board, it would still be balanced, but again, it wouldn't be reduced. So this is just a useful trick. I highly recommend using it. Only use it when there's just one atom left to balance. And I think you'll find it very helpful. All right, so until next time, I'm Derek Genova. Have a delightful day.